Example 5.1, use the shooting method to approximate the solution of the boundary value problem y double prime minus 2y equal to 0 given the initial condition y0 equal to 1.2 and another boundary condition y 1.0 equal to 0.9 with step size 0.25. So in shooting method, we must know the steps, okay? So number 1, convert the boundary value problem to initial value problem. Means that we want to convert the second derivatives into two equations of first derivative. Number 2, we will use the first guess and solve by using Euler method. Next, do the second guess and solve again by using Euler method for this new guess value. Number 4, we will do extrapolation, which means we will get the new value, and from this we also employ Euler method. Okay, so there are 4 steps in shooting method. So let's do one by one. Number 1, given the equation y double prime minus 2y equal 0, you can rewrite this as y double prime equal to d2y dx square minus 2y equal to 0, and we can make the second derivative as the function where we put the rest of the terms to the right hand side. So this is your equation. So step 1, let z, we introduce another variable, let z equal to dy dx. Now the first equation is dy dx equal to z. This is what you introduce, okay? The second equation, d2y dx square equal to 2y. What is d2y dx square? Actually, this is d dx of z. Or if you derive this, z is dy dx, so it's equal. So we take the equation of dz dx, okay, equal to the right hand side, which is 2y. So this is our two equations of IVP, right? And then let's determine the initial value problem. dy dx equal to z, we want to put the initial value y0. y0 can be obtained from this initial value problem, initial condition. y0 is 1.2, so no problems there. And for the second equations, we need to determine z0. Now we don't know, okay, there is no information about z0. That is why we need to guess, okay. Let's say I guess the value is negative 1.5. This is our guess, okay. So this is the step 1. Step 2, first guess Euler method, okay. In step 2, our first guess, just now we set z0 equal to negative 1.5, and we want to solve by using Euler method. Okay, remember Euler method formula is xi plus 1 equal to xi plus h, and then yi plus 1 equal to yi plus f1h, and we have z, so zi plus 1 equal to zi plus f2h. So what is f1 and what is f2? This is f1, this is f2. Now your equation of Euler method, let's replace the value. X is still x, so we remain all the letters, right? We have x, y, z. Xi plus h, our h is given as 0.25. Okay, remember your h is given. Yi plus 1 is yi plus f1. F1 is z, so we write zi times h is 0.25. Okay, then zi plus 1 is zi plus, what is your f2? F2 is 2y, so 2yi times h. So we will apply this formula to make the tables of Euler method. So we start by column I, start from 0, and then column of x start from 0. How we get those value? This is the indicator x start, and this is the value of xn. Okay, so x start from 0 until 1. So we start 0 and add the step size 0.25, add another 0.25. So by using this increment, we get 1. After we get 1, we stop. Then for I, we know we have 4 iterations. Okay, then we want to make the column for y. Y start from 1.2. The first value of y is 1.2. Okay, and then we want to make a column for z. The first value of z is taken from our guess, okay, negative 1.5. So this is our table, where by now we can fill in the column I, column x, and first value of y, and then the first value of z. So our task is to find the value. Okay, you need to calculate y1. Y1 means you iterate, the iteration is I equal to 0. Okay, y1 is y0 plus z0 times 0.25. y0 is the first value of y, 1.2. z0 is negative 1.5, 0.25. We'll calculate this. So we will get 0.825. So we will put this value in the table. Okay, then let's find z1. z1 by the formula is z0 plus 2y0 times 0.25. z0 is negative 1.5 plus 2y0, and then we will get negative 0.9. Okay, so we fill in the table negative 0.9. We need to continue the process for I equal to 1 to find y2. y2 is y1 plus z1, 0.25. y1 is what we obtained earlier. z1 is also the value that we calculated before. So now you can derive this, right? y2 is 0.6. And you have to do the same thing for z. Okay, z2 is z1 plus 2y1, 0.25. z1 is negative 0.9 plus 2y1. Now your z2 is negative 0.4875. So you can fill up the table here. Negative 0.4875. You have to continue the process, okay, until you complete the iteration. So now I give you all the values. You can derive this by yourself. Now your Euler table is complete. Now we refer to the last value, okay, because in this condition it is stated that y1 equal to 0.9. So from the table, y1 is this, okay, when x equal to 1, your y is 0.4312. So you can write y1, what you obtain is 0.4312. Is it equal to 0.9? That is the desired result. No, it's not equal to 0.9. So we will continue with the next step.